Order of operations is a way for all of us to simplify an expression and arrive at the same answer. So you're probably familiar with this as Pemdas, which is an acronym, meaning parentheses, exponents, multiplication, division, addition, and subtraction. So we would start with parentheses, do those first, moving along, ending with addition and subtraction. So next to all of these over here, I have different notations that are used for each of them. The only real confusion I think with the notation would be with parentheses. It can mean sometimes just work within there first, but if you just have like one value inside parentheses, like -4 times 2 or 3 times 1.8, that really just means multiplication. Another point of confusion is with multiplication, division, as well as addition and subtraction. We perform those from left to right as they appear within an expression, and we'll check that out in example 1. But before we do that, I want to justify the rationale for this, like why do we even need an order of operation? If we look at this example of 5 plus 2 times 6, someone could come along and say, well, to simplify this, I'm going to add the 5 and the 2, which is 7, and then multiply by 6, which is 42. But someone else could say, well, I guess you could first multiply the 2 and the 6, which gives you 12, and then second add the 5, which gives us 17. And here we have two different answers because we took two different approaches, and we do not want that to happen. So this is in fact the correct way to approach the problem, to first multiply and then add, whereas adding first and then multiplying, we will consider that to be incorrect. So 17 is the right way to do it. Now let's use this in example 1. We have two different parts here. Starting with -3 plus 5 times -2 plus 7 minus 8 cubed. What do we have here? We have two sets of parentheses, but really over here this just means multiplication since it's only -2 from here to there. Whereas this 7 minus 8 in the parentheses means, okay, we have to simplify that first before moving on. So I'm going to start right here. Copying everything down, we get -3 plus 5 times -2 plus, all right, 7 minus 8 in parentheses first gives me -1 cubed. Okay, second would be, since the parentheses technically have been solved, is to now apply this exponent of 3 to -1. -1 cubed is equal to -1. So we get -3 plus 5 times -2 plus -1. I'm going to rewrite this one more time. If you have a plus -1, you could just switch that out to subtraction, so I'm going to do that. We have -3 plus 5 times -2 minus 1. You could have left it alone, but these do mean the same thing. Okay, next we have addition, subtraction, but then also this multiplication. So I'm going to solve that next. Okay, this is -3 plus, all right, 5 times -2 is a -10, and then we have -1. And again, you could say, well, this is really -3 minus 10 minus 1. And we are only left with subtraction. So we have -3, we're taking 10 more away, that's -13. One more takes us to our final answer of -14. All right, let's try this in just a slightly different example, something with some division in it as well. I'd like to simplify 5 squared plus 20 divided by 4 times 3. So I chose this one just because it'll illustrate something going on with steps 3 and 4. But to start with, I look at this expression, I don't see any parentheses, so I'm going to start with exponents, which is right here. 5 squared. 5 squared is 25, and I just copy down the rest. All right, so it would be a mistake to now look at this expression and say, oh, well, Pemdas means I would multiply before division. But if you look at step 3, we do multiplication and division from left to right as they appear. So when you scan this expression, we get to division first and multiplication second. So we're actually going to divide 4 into 20 before multiplying by 3. So just being careful there. It's going to be 25 plus 20 divided by 4 is 5, and then I copy down the multiplying by 3. So here I have addition and multiplication. I'm going to multiply the 5 and the 3, which gives me 15. The only operation remaining is addition, so 25 plus 15 is 40, and that's the final answer. I think one other thing to point out is, as you work through these, you probably could notice, like back in this example, there would have been nothing wrong with multiplying the 5 and the -2 before dealing with this exponent over here. So as you become comfortable with order of operations, like you'll notice these types of things. Like it might not be absolutely necessary to be very strict when following this if what you're doing won't affect your final answer. If that's a problem, that's okay. You could really just follow this in a strict sense and always arrive at the answers that we have here too. Okay, in the last example, here I'm throwing in some absolute values, square roots, and fractions. And I put this rule that precedes this here. If you see a square root, a fraction like this, or absolute values, they contain implied parentheses. Here's what I mean by that. Here we have 10 minus 15 in the absolute value. As we discussed in the previous lesson, you have to simplify this first before taking the absolute value. So in some sense, we're saying there are parentheses around the 10 and this 15. We don't write it because it looks kind of messy, but it is implied by the notation. I have to simplify this first before dealing with the absolute value. Same thing goes for the square root. I have to simplify what's under the square root first before applying the square root to that number. So let's try it out. Okay, I have the absolute value of 10 minus 15. And like I said, I'm going to subtract 10 and 15, which gives me -5. And then I'm going to copy down the square root. Now, under the square root, I have addition and I have exponents. So I'm going to apply the exponents first. -3 squared is 9. -4 squared is 16. And I'm adding those two together. Okay, moving forward, the absolute value of -5, well, I know that's +5, so I'm just going to copy that down. But again, with the square root, I can't take the square root yet because there are two numbers being added underneath it, 9 and 16. So I have to simplify that first. 9 and 16 is 25. I have 5 plus the square root of 25. I better get the square root of 25 being 5. And then it takes me to my final answer of 10. So again, implied parentheses. All I mean is we have to simplify under the square root first before applying it to get to the number 5. Likewise for the absolute value, I need one number before applying it. The other place where this shows up is if you have a giant fraction like this. The implied parentheses means you have to simplify the numerator and the denominator separately before you actually divide those two numbers. So let's try this one out. Starting in the numerator, we have 2 cubed plus 6. I want to get that down to one number first. So let's see, 2 cubed is 8, and then I have this plus 6. That's being divided by, well, 9 minus 2, I'm going to do that separately, and that is equal to 7. So here, I'm working with the numerator and the denominator separately before I divide it. So again, I have to simplify the numerator. We have 8 and 6. I'll kind of go across here. 8 and 6 is 14 divided by 7. And now everything is fine. I'm dividing. There's just one number in the top. There's one number in the bottom. And that simplifies to 2 over 1, or just a final answer of 2.